Okay, ladies and gentlemen, welcome back to the lesson. Now, this is the first of the two videos that I told you I would be creating. One will be looking at the tabular approach in handling learning curve questions, and the second will be looking at the algebraic approach. Now, I have gone ahead and typed up the question that we are going to be using to illustrate the tabular approach. Now, one of the things I mentioned to you in the first PowerPoint video was that by looking at how the question is presented, you will know which of the methods you should use. And so, as I go through this particular approach, I will show you the evidence that indicates the approach to be used. So let us begin. Now, the question is Captain Charles, and he and his team have designed a new fishing boat, and they have given us some costs. Now, this cost relates to the first boat. It cost $6,000, and you know it's not Jamaican dollars. It costs $6,000 for the raw material for one boat. So if they are thinking of making more than one boat, let's say they're making two boats, then the cost of the raw material will be 6,000 times 2, and that will give you $12,000. So this raw material cost is variable, as you well know, depending on how many boats are being made. But this is the costing sheet for just the first boat. The question goes on to tell you that the first boat took 600 hours to be constructed, and the staff was being paid $5 per hour. Let me change this to $5 per hour. This is the labor rate. It's not per unit, it's per hour. Because you have to pay the people for the time that they worked. 6,530 is probably because I'm probably tired. All right, let's correct that. So the raw material cost is $6,000 for a boat. The labor for the first boat was $3,000. And the overhead cost is a percentage of the labor. And so in this question, the overhead absorption rate is 50% of the labor. So it means, therefore, that the labor in this instance will create an overhead cost of $1,500. So the grand total cost for building this particular boat, the first fishing boat, is $10,500. The markup or the profit margin on this thing is 25% on cost. And so 25% of $10,500 is $2,625. So the final selling price for the first boat is $13,125. Now the thing to note is that the selling price is affected by the labor, and that the labor is affected by the amount of hours, labor hours, time spent in making the boat. To continue with the question, it says the fishing boat will be sold at 20% on cost, and most importantly, there is an 80% learning rate or learning curve expected to be applied to this particular job. Now, Captain Charles wants to know what to charge as selling prices in the following instances. First, he wants to find out what price to charge for the second boat. He also wants to find out what price to charge if somebody is buying the third and fourth boat together. And the last option, if somebody wants to buy all 8 boats ordered together. Now here's the key. I am going to show you a table that you would have to create. It doesn't have to be so elaborate, but I'm doing it like this so that it will help you to understand what's happening. So this table, hence the tabular approach, carries with it some specific data. And I'm going to show you now how you know that it's a tabular approach to use. Let's start with our first column, in column B. The heading cumulative number of modes means that for each of the options or the rows that I'm going to create, I keep adding on more and more boats, hence the word cumulative. So I'm starting out with the first boat that they're going to make. Then I'm going to double it. 1 multiplied by 2 is 2 boats. Then I'm going to double it, 4 boats. Then I'm going to double it, 8 boats. So notice that I have been doubling the output of boats. Now, when you look at the question, look at some keywords. 8 boats. Third and fourth boat. The second boat. These are the keywords I wanted to pay attention to as we work through the tabular approach. Now, we were told that an 80% learning curve rate will be observed. What does that mean? From the costing structure, we find out that the time taken for the first boat is 600 hours. So I'm going to post it here as the average time per boat if you're making 1 boat. Now remember when I did my PowerPoint slide, I showed you where each time John made product X, the average time of each unit reduced on each occasion. 3 occasions, he made 1 unit, then he made 2 units, then he made 4 units together. And we noted that the average time on each event reduced. So what this means is that if Captain Charles is going to make 2 boats together at the same time, it means that the cumulative average time for the boats are going to be 80%. That's the learning rate multiplied by 600 hours. So it means that the average time for each boat, each of these 2 boats, is 0.8 multiplied by 600, 480 hours. Now, what does it 480 hours mean? It means that on average, each of these 2 boats will take 480 hours. Let's go back now to the instance where we are doubling the output. Now we're making 4 boats. What is the average time on each? The cumulative average time equals 80% multiplied by not 600 hours now, but 480 hours. Where does that leave us? Let's see. 384 hours. What does this tell me? That each of these 4 units takes 384 hours. And let's apply the last learning rate. So in this instance, when 8 boats are being made at the same time, when these 8 boats are being made at the same time, let us see how the learning curve is going to predict the labor hours on this. 80% times 384 hours. So the time to make 1 unit on average is 0.8 times 384. So it means then that each unit, each of these 8 boats will take 307.2 hours. Now let's look at the second column. The cumulative total time, if you remember from my PowerPoint, looks at the average time and multiplies it by the number of units, in this case boats. What's the cumulative average time when 1 boat is made? 600 multiplied by 1. My coordination is off again. Let's look at the cumulative time for 2 boats. If the average time to make 1 boat is 480 hours, it means that if they're going to make 2 boats, they should expect it to take in total 960 hours. Next one. 4 boats times 384 hours, 1,536 hours. Last one. 8 boats, each taking 307 hours, 7.2 hours. 2,457 hours, or 57.6 hours. So these are the times taken to make these quantities of boats. Now, I need you to get this. These next 2 columns will have no data because it is talking about the additional boats made. Well, we can put in the 200 because prior to this 1 boat, nothing was made. So here we're making 1 additional boat. Okay? And the additional total time is 600. Comparing it to the situation where nothing was there before. Okay? All right. So in our next row, we're going to now compare it to the previous situation. So if in this instance we are looking at 2 boats, it means that the additional boat in this case is 1. Because 2 boats previous to this, it was 1 boat. So additionally, 1 extra boat was made. In this one, 2 extra boats were made. The third boat, in this one, the additional boat that was made was the second boat. In this one, so in this one here, when they made 4 boats, it was 2 boats more than that event. In this situation, it is 4 boats more than that event. So it means then that the additional boats made when compared to the previous event is the 5th, 6th, 7th, and 8th boat. Now let's look at the additional time. The first boat took 600 hours. The second boat, if both boats here cumulatively took 960 hours, and the first boat took 600 hours. It means the second boat is expected to take 360 hours. This is the additional total time that extra boat would take. Now let's look in the third row. In this event, they're making 4 boats compared to the previous event where they're making 2 boats. So the additional amount of boats was the third and fourth boats. So the additional time it took to make those 2 boats must be the 1536 minus the 960. So the third and fourth boat is expected to take an additional 576 hours in the last instance. We're looking at 8 boats being made. The previous 4 boats took 1,536 hours. That's the expected time. So the additional boats, the additional 4 boats would take 2,458 minus 1,536. So the additional 4 boats should take 922 hours. Now, what does all of this have to do as evidence or provide? How does it provide evidence that this is the tabular form? The first boat, the second boat, the third and fourth boat, all 8 boats. So notice the numbers that are being used, the number of boats that are being used that you need to get a query on. The second boat, the third and fourth boat, all 8 boats. All right. So let us see now if we can apply the information, because look at this. The second boat would take that time. The third and fourth boat would take that time. And yes, you guessed correctly. All 8 boats would take that time. So once we've reached this far in the calculation, the question is finished. Let's go back up and see how it's going to apply with the second boat. Now remember, now we're only making 1 extra boat. So the material cost will be 6,000 still. So let's label it the second boat and put our calculations up here. So for the second boat, it's just 1 boat. So it's gonna take $6,000, just like the first boat. But where the difference comes in is the labor cost. It's still $5 per hour, but the second boat, rather than taking 600 hours, the second boat is going to take 360 hours. 360 times 5. So let's put that in. So notice now then that in making the second boat, the labor cost has dropped from $3,000 down to $1,800. The overhead cost is 50% of that figure. And then we can copy and paste the formula. Let's try this again. Control C, Control V. So it means then that Captain Charles can charge for that second boat $10,875. So you're going to notice that applying the learning curve principle, the price for the boat has dropped. First boat sells for $13,125, but the second boat, the staff is becoming more efficient. They're learning how best to make use of the time, and so their labor time and hence their labor cost reduces. Let's look at part B. The price per unit for the third and fourth boat. So we're going to calculate the two of them together, and then at the end we're going to divide that price by 2 because I want the price per unit for the third and fourth. So because we're making 2 boats, third and fourth boat, so we're dealing with 2 boats. So it's 6,000 multiplied by 2. The labor is now going to be 576 multiplied by 5. The overhead cost is again 50%. Let's copy this. In fact, we can copy all of this. So 50% of the labor is 1,440. Then we add up everything to get our total cost. And then we apply our markup. And so we end up with our selling price for the 2 boats. So it means then that if we divide the 20,400 by 2, then we'll get the price per boat. And notice it has dropped even further. 10,875 for this boat. But if you buy the third and fourth boats together, you get them at a cheaper price. Because again, the construction crew are getting more efficient. So the price per boat is 10,200. Now let us look at the last one. The price if all 8 boats were ordered together. 8 boats. So we can expect that our raw material will increase. So it's 6,000 times 8. Now let us go to the table to find out what is the labor cost for all 8 boats, and I did highlight it, and it is 2458 hours. 2458 hours multiplied by the same $5 per hour. The overhead cost is 50%, and so we can complete our calculation by copy and pasting. So the 8 boats come to $83,044. So if we divide that figure by 8, so now what we notice is that the price seems to have, can we call it stabilized? Let me double check the calculations. 8,2458 times 5, 50%, picking up 25%, and multiplying by 8. Okay, if that is the cost, that is the cost. So we go down. Price would be total price would be $83,044. All right, so that concludes our tabular approach. So notice the data that they asked for were doubles, 2, the third and fourth, the 8. All right, so if they could have asked for the 5th, 6th, 7th, and 8th boat, in which case we'll be using this as the labor hour rather than the full 2,458 for all 8 boats. All right, so this is the tabular approach, and you can go over the video. And remember, I'm not going to be asking you any multiple choice questions after this, so you can relax. All right, well, thank you very much, class, for sitting and watching. All right, and let's go to the next video.